Okay, question number 2. Again, it's from chapter 3. The question is, we have a box exerted by two forces. So you can clearly see from the figure here, the force is 700 and 300. So both are to the right, but for this 700 force is having certain angle from the horizontal. Okay, that is 30 degree. And determine the magnitude of the third force. Okay, we need the third force that needs to be exerted so that the box is in equilibrium, meaning that the summation of force acted on the box is 0 when we say the box is in equilibrium. So this is the keyword of this question. Let us first label our forces. Let us label F1 for this force, and for the force up here is F2. Okay, from these two forces, the only force that we need to break up into X and Y component are F2 because we have angle. Okay, so your F2 here is going to have F2x. This is the angle, and the angle here is actually equal to angle at this position. And also we have F2y. So to get the summation of force is equal to 0, okay, we are going to do for both X and Y component. So we know that summation of Fx is equal to 0, and our summation of Fx is F1x plus F2x, and we need a third force, okay, as the question asks us to find the third force. So we are having F3x, so it's equal to 0. Okay, then we can calculate our F3x. So our F1x is equal to F1, it's 300. Our F2x is F2 700 cos 30, and the direction is to the right, so it is plus F3x equal to 0. Then using your calculator, you'll get your F3x is equal to 906.22 Newton. So we'll be doing the same thing for y-axis. Summation of Fy is equal to 0. Generally, we are going to have F1y plus F2y plus F3y equal to 0. We don't have any F1y because it is only acted in X direction. Then it's going to be 0 for F1y. F2y is negative because it is acted downward. Okay, so negative 700 sine 30 degree plus F3y equal to 0. Okay, you're supposed to get your F3y is equal to negative 350 Newton. Okay, so to get the resultant, as we have X and Y component of F3, we are going to use this equation. It's square root summation of Fx squared plus summation of Fy squared. Okay, so we have got our F3x and F3y. So F3x and F3y. Then we substitute the values. Sorry, we're supposed to have negative for F3x here. So it's going to be negative 906.22 squared plus negative 350 squared square root, and our resultant force is going to be 971.46 Newton. Okay, so that's how we get our third force. This is the third force that needs to be exerted. Okay, this is the third force that needs to be exerted to this box so that this box is in equilibrium.